Today we will learn about Program Evaluation Review Technique, which is also known as PERT. So first, let's talk about why we need this technique in evaluation. You will work on a lot of projects in your career, a lot of different types of projects. Some of them will be unique in nature, in the sense that there will be new and unique activities which may not have a fixed time. These activities are either unique or non-repetitive, so time duration cannot be determined precisely. What can you do in this scenario? This is where PERT comes to the rescue. Let's consider a scenario where you're preparing for your exam and your exam is due within a month. Being good students that you are, you prepare a proper plan or schedule of studies and subjects that you will follow till the end of the day of your exam. 3 days down the schedule, you feel that this schedule is not working out, so you make a new schedule. You also consider few other aspects such as the speed of your studies, difficult subjects involved, and thus you make a new schedule. 7 days down the line, you feel even this schedule is not really working out, so you make another schedule. This isn't a unique scenario at all. We all go through this even in our careers, which is where PERT will be very helpful. In PERT, at the start of the project itself, there are 3 estimates of activity times. The first is the best possible time, which is called optimistic time, and it is denoted by O. Second is ideally the time it should take considering normal circumstances, which are called most likely time, also denoted by M. And third is the worst possible time considering contingencies, etc. This is called pessimistic time, denoted by P. The formula for calculating the estimated expected time or the mean duration of the time is equal to O plus 4 times M plus P divided by 6. We use a weighted average calculation because statistically we find that the largest portion of a randomly occurring population of data will be found close to the mean. So that's why the weight of the most likely time is 4 times as compared to the optimistic time and pessimistic time, which is 1. The formula for variance is P minus O divided by 6 whole square. And now we will solve an example for PERT. The question is, determine the critical path of the project and find the probability of completion of the project in 30 weeks and 20 weeks. Also find the duration of the project. So now the project network has already been given in the question. Along with this, optimistic time, most likely time, and pessimistic time of each of the activities are given. So the first step is to find the values of mu, that is the mean estimate time, and sigma square, that is variance. The formula for mu is O plus 4 times M plus P upon 6, and the formula for sigma square, that is variance, is P minus O upon 6 whole square. So based on this, you need to calculate the value of variance and mean for each of these activities. The next step is to determine the critical path using the mean duration as the durations for each of these activities. The students have to use the critical path method to determine critical path, but right now I'm skipping that step. The critical path for this network is A, D, E, F, H and J. Now I will calculate the total duration of this path, which will be the summation of all the mean estimates, 2 plus 2 plus 4 plus 8 plus 3 plus 5, which is 24 weeks. Now 24 weeks is also the duration of the whole project. So we have found out the duration of the project. Now it is asked to find the probability of completion of the project in 30 weeks and 20 weeks. For this you need to calculate the Z value. The value of Z is T minus mu upon sigma. Mu is the summation of the mean durations, which we have already calculated. This is 24. The formula for sigma square is the summation of the variance of all the critical activities. Mind you, please don't take the summation of all the activities, but only take the summation of critical activities. So this is 1 by 9 plus 1 by 9 plus 4 by 9 plus 4 plus 1 by 9 plus 1, which is 61 by 9, and then sigma is root of 61 by 9, which comes out to be 2.6. Now the value for Z1 is for 30 weeks, 30 minus mu is 24 upon 2.6. This is 6 upon 2.6. This is 2.3. Similarly, Z2 has been calculated, and to find the probabilities you need to refer to the standard normal distribution table. Please refer to the next video to understand this.